Hello Math 7 students, this is Open Up Resources, Unit 5, Lesson 2, Changing Temperature. So we're going to start with one of my favorite warm-ups, which one doesn't belong. So you've got, they're listed as 1, 2, 3, 4. Which pair of arrows doesn't belong? Just to make sure you understand the situation, here's the number line. This is the pair of arrows above it that we're talking about. Number 2 is this number line with that pair of arrows, and so on. So just take a couple seconds of quiet think time. Form an opinion. Which pair of arrows doesn't belong? Make sure you're able to justify why. We'll pause the recording as you take your own think time. Okay, and now that you've formed your own opinion and you have chosen which one doesn't belong and you have a good reason why, I now want us to turn to our tables and talk at our tables to explain and justify which one doesn't belong. Listen to those opinions at your table and see if there's anyone who has an opinion that's different from yours. We're going to pause the recording as students discuss at tables. All right, now I want to know, now that you've had a chance to kind of bounce some ideas off of your group members, now let's come together as a whole class. Which one doesn't belong? Why? Bethany. Say that again. They're both in the same area and what? Okay, so number 3 is staying in the same area of numbers. So like it goes up 3 and then the arrow goes back 3, so it didn't change. Okay, so I agree. I am convinced 3 is the one that doesn't belong. Who disagrees? Who wants to argue now? Yeah, that's what I thought. That's why I love this one. Jason. Okay, I thought I was convinced with 3, but now I'm definitely convinced. Number 4 doesn't belong because these arrows are going in the same direction and they're going towards the negatives. Okay, I'm convinced. Who would like to argue with that? Vivian. Or Kylia, I'm sorry, Kylia. Okay, I am definitely now convinced that number 2 is the one that doesn't belong. This one starts at 0 and then when it goes in the other direction, it passes that 0. It goes the same distance that it went forwards, backwards, and then some. So yeah, I'm convinced it's definitely number 2. Who wants to argue? Daxton.
Here's what I found.
Are we seeing that behavior with all of them in a way? That one arrow or the second arrow starts where the other one stops? We're kind of seeing that behavior with all of them, huh? So here's why I love the which one doesn't belong exercise, because are any of them, the students who shared, are they incorrect? No, every single one of these could be argued. The whole point is forming an opinion and justifying it. Math practice 3. Construct your own viable argument, but then listen to what others have to say. Critique their reasoning as well. So I think that there is a great argument for each one of these, and we're ready to move on. The next exercise is warmer and colder. It says complete the table. And then it says, and draw the number line diagram for each. Now, the way that your guys is printed, the number line diagrams are actually on the right-hand side. So we're going to start by completing the table. I'm going to do it here on the screen. We're going to complete the table, and then you will complete the number line diagrams here to match it. So we have the situation where we already saw on a previous lesson that integers can be represented with, or I'm saying that wrong, temperature is a good application of integers where we can have positive and negative. And so suppose the temperature outside starts at 40 degrees Celsius, but then it changes. It gets 10 degrees warmer. What is the temperature now? It's 50 degrees. So we want to write an addition equation to represent that. 40 plus 10 degrees warmer is equal to 50. So that one's done for you. I don't think you need any extra guidance from me, so I'm going to pause the recording as you work in your groups on B, C, D, and E, and then we can start worrying about what that looks like on the number line diagram here in a second. So with your groups, B, C, D, and E, pause the recording now. All right, now that you've worked in your groups, let's come back together as a class and let's make sure that we're all on the same page here. We did A together, it's already done for us. B, we start at 40 degrees. Notice this sign right here. What does that mean? Bethany. Yeah, it's a positive 40. Sometimes mathematicians are lazy and we don't always put the sign if it's positive. I like that it's doing it now so that we really are in the habit of thinking of positives and negatives. So positive 40 degrees, but then it gets 5 degrees colder. How am I going to represent 5 degrees colder? I know what you guys started to do instinctually, but what should we do when we're thinking of 5 degrees colder? Landon? Not 40 minus 5. That's what we want to do because all of our experience, we're like, oh, if we're getting smaller, we're subtracting, right? But what's really happening, 5 degrees colder, we can represent that with a negative 5. Exactly. So that means that the final temperature is going to be, yes, Jason? Yes, 35 degrees Celsius. How did we get there? What is the addition equation? Do you see how it says what is the addition equation? Can I write 40 minus 5 and keep that an addition equation? We really can't because of the subtraction, right? So that's why I want us to be thinking this as a negative 5. So what am I going to write? I've already heard from these students. I need fresh new hands. You all talked about these in your groups. You listen to your groups. That is so much better. That's the engagement I need to see. Bria. Yes, exactly. 40 plus negative 5, and that is equal to 35. Notice how I wrote that. I put the negative 5 in parentheses. You don't always have to do this, but in the beginning, it's better because this can look a little bit confusing, right? We're not sure how to say that, but if we say, hey, that is a negative 35, we emphasize that it's negative by putting it in parentheses. It makes it, or not negative 35, I'm sorry, negative 5. It makes it a little bit easier to see what's happening there. Okay, let's continue on with these. We're going to go through them a little bit quicker. I'm just looking for volunteers, and I want to see those hands. Hannah, go ahead and do the next one. Great. Yeah, so you're finishing at B, right? 40 plus a negative 5 is equal to 35. Let's move on to C. 40 degrees, and it gets 30 degrees colder. Jaden. Yeah, 40 degrees plus a negative 30 degrees, keeping it an addition equation, is equal to 10 degrees. So the final thing after it gets 30 degrees colder is it is 10 degrees Celsius. Next one, D, 40 degrees, and it is now 40 degrees colder. Caitlin, S. Love it. 40 plus a negative 40 is equal to 0. So the final temperature there is 0. This is an important concept that you will be exploring more tomorrow. 40 plus a negative 40. If we were representing these with rocks and balloons, what would we call that? Caitlin? Yeah, they're 0 pairs, exactly. We're gonna add some new vocabulary to that concept tomorrow. Last one, 40 degrees, but it gets 50 degrees colder. Adia. Great, 40 plus a negative 50 is equal to a negative 10. So we've represented these like this is pretty conceptual. We can easily figure these out, but now let's tie this, what feels like it's pretty instinctual, to a math concept. We're going to do this with a number line. So I'll help you out with the first one. We're starting at 40 degrees. How did we start at 40 degrees? I like to draw an arrow, kind of like we just saw on our warm-up, the which one doesn't belong, that starts at 0 and goes up to 40. And it's getting 10 degrees warmer. So starting at 40, it is going up an extra 10 degrees. That's why it ends at 50. Okay, so that's what a number line diagram of 40 plus 10 equals 50 is going to look like. What is that going to look like for part B? 40 plus a negative 5 equals 35. Will you quickly, just a quick 5-second discussion at your tables? I'm not even going to pause the recording for this. What do you think that's going to look like for that diagram? Ready, set, go. Okay, and now share with the recording. What's going to happen? What needs to change? A new hand here, Belen. It's going to go back. What do you mean by it's going to go back? What's going to go back? It's going to go to 35. So I'm going to start in the same place because all of these, we all start with that 40. So I am going to be super lazy and I'm just going to duplicate that first one. And now that I know where I'm starting at that 40, now I'm going to go back those 5 degrees, right? Doesn't that look kind of like what you saw on our warm-up, the which one doesn't belong? Yeah, now we can kind of make sense of why those arrows might have been going in different directions. Okay, I'm going to let you work on the next ones with your group C, D, and E. This should take you roughly 60 seconds or so, and then we're going to come back together to do these up on the board. Pause the recording so you have time to work on these on your own. Ready, set, go. Okay, now that we are finished doing that, now it's time to check our answers. I have some students who are ready to go up to the board. I've already noticed that I've already drawn the 0 to 40 arrow. We know where our starting point is. You just need to finish up the problem. So the students that I invited up, go ahead and do C, D, and E. As the students are up, I'm going to pause the recording one more time, so all of a sudden you're just going to magically see the answers appear. Okay, this is fantastic. How did you guys do compared to what we see up on the board? Any questions, comments, concerns? Okay, let's do this one more time. We now have a new starting point. Now we're starting at -20. We've got these various changes that are happening. Again, we are going to pause recording as students work in groups, and then we'll put the answers up on the screen. Pause recording as you do this on your own. Ready, set, go. Okay, let's check our answers. I'm going to go through these quickly. So -20 is our starting point, so I'm starting at -20. It's getting 30 degrees warmer, so 30 degrees warmer. Positive or negative this time? Yeah, that's going to be a positive. And since I'm writing an addition equation now, it's -20 plus 30. Man, I'm kind of struggling with that. I wonder if the number line can help me with this. So I'm going to go from 0 to -20. I'm going to try and do that a little bit neater. 0 to -20 so I can see where I'm starting. But then it's getting 30 degrees warmer. So I'm going to go 5, 10, 15, 20, 25, and 30. Where did I end up when I did an arrow that went to the right? 30. Where did I end up, Caitlin S? Yeah, at 10. So -20 plus 30 is equal to 10. That final temperature is a positive 10 degrees. You can make the choice here. Do you want to include the positive sign? Or do you want to just assume that if we don't have a sign, it's going to be positive? That's up to you. My personal preference, we're normally not going to see the positive sign like we see here. So I am going to choose not to include that, but that is up to you if you want to. Okay, the next one, we started at -20. It is now 35 degrees warmer, so plus 35. I can use kind of what I had the last time to help me out. So again, 0 to -20. 35 degrees warmer, so this got me to 30. 35 is going to be that extra 5. So it looks like the final temperature is now a positive 15. How are we doing so far? Good. Let's finish up then. -20 is where I'm starting. -20. It's 15 degrees warmer this time. Again, the number line model really can help us see what's happening. -20. Warmer by 15 degrees. 5, 10, and 15. Looks like I'm still in the negatives though. And the final result is a temperature of -5. Last one. I want someone to talk me through this one. I don't want to give away the answer. I want someone to talk me through it. Nisi. Great. I'm going to pause there. What Nisi said for the recording, -20 plus a -15 is equal to a -35. How did you know it was plus a -15 here? The question is, how did you know that it was plus a -15? All these others, we were adding positive numbers. How did you know it was supposed to be a negative here? Yeah, 15 degrees colder is going to be a -15. Good. So -20 plus a -15 is equal to a -35, but will you tell me how you got there? Let's look at that number line. Let's move on to somebody else. Who can explain that? Angelo. Okay. I go up to 35, so all the way up to here? I go negative. And how much more negative am I going to go? 15. Okay, so continuing -1, 5, 10, and 15, like that? Okay, great. So I have some questions for you after this activity. How do we represent on a number line? How do I represent when the temperature is increasing? Thank you for these hands. Let's start with Landon. When an arrow is going up, or what direction would that be on these number lines? To the right. Exactly, yeah. How am I going to represent a temperature decreasing? Jaden. The arrow is going into the negatives or to the left. Great. So my next question then is, how can I represent two numbers being added together? What is the sum of two numbers? How do I represent that? We've done that on these number lines, right? So how are we doing that? Let's discuss at our tables first. We'll come back together as a class, discuss at your tables, just a few seconds. How am I showing the sums or these additions? Okay, and now come back to me and tell me, how am I representing these sums? How am I doing this addition on the number line? I need some new hands. I've called on each of these students, called on those students too. We'll go back to Briya this time. Give me more. What about the arrows? What am I doing with the arrows? Okay, so if I'm going up, then that arrow is going to the right. If I'm going down, the arrow is going to the left. But how do I show this addition? A little bit more than that. Because look at the screen for a second. This would just be a negative, right? This is just a positive. Oops. This is just a positive, just this one. How am I showing the sum? How am I showing that they're being added together? The position of where they're at is kind of the key here. What do you... Exactly. The second arrow is starting where the first arrow ended off. So this first arrow goes from 0 to negative 20. The second arrow starts right there at negative 20 and then goes whichever direction it needs to. So in this case, it went to the right. And in this case, it went to the left. Yeah, great job. Okay, so ending, the first arrow ends tells us where the second arrow needs to start. Let's move on. Winter temperatures. So one winter day, the temperature in Houston is 8 degrees Celsius. I want you to find the temperature of these other cities. There's a little bit less structure here. We don't have a table to help guide us through it. We don't have the number lines, but just because they're not here doesn't mean we can't use them. We can still use them if we would like to. So go through each of these. We'll do the first one together. In Orlando, it's 10 degrees warmer than it is in Houston. Wait a second. How warm is it in Houston? 8 degrees. Okay. So I know that I'm starting at 8 degrees, and in Orlando it's 10 degrees warmer. Tell me what I'm going to do here. Thank you. I need to see some new hands. I'm going to start calling on hands that I haven't seen at all yet. Like, I've called on you though. I've called on all of you. We'll go back to Angelo. You're right, but how did we get that it was 18 degrees? What did I do? Because I only see 8 degrees and then I know that it's 10 degrees warmer. What am I doing with those numbers? I'm adding them together. 8 degrees plus 10 degrees is equal to 18 degrees. This is kind of a mix of abstract and quantitative because I'm using those units. Purely abstract would be 8 plus 10 is equal to 18. That's probably a little bit better. Otherwise, those degree signs in an expression or equation like this kind of start looking like zeros. So in Salt Lake City, it's 8 degrees colder than it is in Houston. Remember, Houston is still 8 degrees. Salt Lake City, it's 8 degrees colder. So what am I going to do here? Adia. Great. And I didn't even take my own advice. I said maybe don't use the degree signs, and I did it anyway. Probably better would be 8 plus a negative 8 is equal to 0 or 0 degrees. Fantastic. Okay, Minneapolis, it's 20 degrees colder than it is in Houston. So remember, I'm still starting at Houston, which is 8 degrees. What am I going to do here? And I love how Adia started to say we're going to subtract 8, but then she realized, wait a second, we want to keep this a negative situation if it's colder, so we're going to add that negative. Let's follow suit there. Nisi, what would we do? Yeah, this one's a little bit harder to try and figure out, right? It takes a little bit more brain power. What are some things that we can do to help us understand that it's going to be negative 12? What are some thought processes going on in your head? Jaden? Okay, let's go to Dexton. Okay, as you were talking, I was drawing some arrows that kind of help illustrate that to make it kind of visual. So here's our 8 degrees. What's going to happen with the first 8 degrees? That's going to kind of zero out, right? That's going to get us to 0. So this is the first negative 8 degrees. And then how many more degrees do I have? Negative 12, right? To get us to that total negative 20. That's kind of, as Daxton was talking his thoughts out, I was drawing it. Does that kind of work? Great way to make it visual, right? Again, it's kind of that number line that's helping us out there. Yes, Angela, you have a question, or are you ready to answer the next one? Okay, in Fairbanks, it's 10 degrees colder than it is in Minneapolis. Did you catch that? Oh, Gunner. Yeah. $12 plus 10. Is that what you said? 12 plus a negative 10? Okay, not too shabby. Math practice 3. Let's critique his reasoning. Gunner, can you find your own mistake? What do you see, Jason? Yeah, in Minneapolis, it's not 12 degrees, it's negative 12 degrees. So with that fix, let's follow that mistake all the way through. Negative 12 degrees plus a negative 10 degrees. What is it, Gunner? Give it another try. Fantastic, negative 22. And again, visualizing our number lines can help us out. We're going negative 12 this way, and we're going to go another negative 10, and that's how I get to the negative 22. Okay, and for the sake of time, so that we can finish up this video, we're going to skip number 5. That means we are ready for our lesson summary. What this summary is all about is just, again, showing that we can express changes in temperature using positive and negative numbers, so using our integers. If it's 42 degrees outside and the temperature increases by 7 degrees, then we can add the initial temperature and the change in temperature to find our new final temperature. So it increases by 7, that's going to be adding 7. Just like if the temperature decreases by 7, we can think of that decrease as a negative 7. So we're still going to be adding that change. That's going to be plus a negative 7. In general, we can represent the change in temperature with a positive number if it increases, and a negative number if it decreases. We're really trying to focus on keeping these addition sentences so that we can get in the habit of thinking of these with positives and negatives. We can also see all of this represented on the number line, and this is a great way to think through some of these problems as they get into bigger and bigger numbers. So signed numbers with arrows on a number line, we can represent positive numbers with arrows that start at 0 and go towards the right. Just like we see here, this is 0 going to the right. That's how we would represent positive 10. And we can represent negative numbers with arrows that start at 0 and go to the left. So if we wanted to represent the addition of these positive and negative numbers, we just need to put the arrows tip to tail. So in this diagram, we see 3 plus 5, 0 to 3. And then the second one, the tail, or the beginning, starts and goes in that direction. So we can see the 3 plus the 5. We can do this even if we have negatives involved. The difference is going to be, we still have the 3, the negative 5 is going towards the left, but notice that they're still stacked tip to tail. That 5 is just going, or the -5 is going to the left. And so we can see that this result is a -2. So that is it for this video. We just have this cool down. Let's go through the cool down really quick. Write a story about temperatures that this expression could represent. Now we're kind of working backwards from what we did previously, where before I would say we're starting at such and such a temperature and we're experiencing this change. And then you would have to write this expression. Now we're going backwards. So pause the recording as you write a story about this expression, and then we can draw a number line diagram. Pause the recording now. Okay, and let's check our answer. We should have written a story that's something like we would start at 27 degrees. We can even call it Celsius, and we can even say in Salt Lake City. And we can see that we're adding a -11. That means it's changing. And if it's negative, that means it's getting colder. So it gets colder, or the temperature drops by 11 degrees. Okay, so draw a number line diagram and represent an expression to represent this situation. On Tuesday at lunchtime, it was 29 degrees Celsius. By sunset, the temperature had dropped to 16 degrees Celsius. So drawing a number line diagram for this. This is going to be the 0, and this is not going to be a perfect one. I don't want to have to draw a 1, 2, 3, etc. all the way up to 29. I just know that this arrow represents 29. And now it has dropped. That means I'm going to be going down to the left. It has dropped to 16 degrees. So I need to know how much did it go down in order to get to that 16 degrees. We can see that is going to be 29 plus a -13 is equal to 16 degrees. Your homework is the Unit 5 Lesson 2 practice problems. All of those relate to what we did here in class today, so make sure you get those done. They are due in our next class. That's it for today. Thanks for watching. We'll see you next time.